Okay guys, this time I'll show you how to create the simulation and then the code for the CNC router. Okay, so let's start with this is your supposed coffee grinder or paper grinder or whatever, and this should be your block of wood. Okay, so let's make it roughly twice the size as your grinder. And the first thing we need to do is, in order for this grinder to fit into this wood block, we'll have to make the cavity a bit bigger. Okay, so what we'll do is basically we'll first take this one and then we'll scale it, create it a bit bigger, let's say about 10% bigger. Okay, so 1.1, that's it. And now we'll basically move it to the position and create a hollow shape within this same size. In order to don't lose this one, let's just copy and then paste, right? So we're creating a copy, and that way we won't lose it. Okay, so now we take our body and we will move it. We'll select the center and the center here, and then we'll just translate it to roughly the middle part. Okay, and let's say 55. That's it. Okay, now we have it where we want it to be, and what we will do is we'll basically create the hollow shape for the middle part of the of our grinder. Okay, so we just go to modify, combine. We'll select target body will be our wood, and then the tool body will be this one, and the operation will be cut. We click OK, and that's it, right? So now we have the hollow shape for our 10% bigger mill. Okay, so what we do next is, well, first of all, we save it. Let's say CNC mold. Okay, save, and then we go from model, we go to cam. Okay, so we'll create the toolpath for this part, and the first thing we need to do is to create a setup. Remember, we start from left to right. Okay, so first create setup, new setup. Okay, and we'll be prompted with this small screen, and we'll need to follow this one. Okay, so first of all, the operation type we will use is going to be milling. Okay, the orientation, sorry, will be this one. The origin, let's assume our origin to be this point here. Let me just, okay, stock box, selected point. Okay, and then we select this point as the origin. Okay, but now we need to change the coordinates. Okay, the y direction must be in this axis, the x direction must be in this one, and then z would be like that. So in order to change this, I'll select the x and y axis, right? So the x axis is this one, the y axis is this one, right? And then z goes downwards like this. Now z should be changed. Let me just flip y-axis just like that. Okay, so now we have x positive to the right, y positive in this direction, and z positive upwards. Okay, so that's the first thing we need to do. We need to set up our coordinates for the machine to identify them. Okay, and now here for the model, I'll just select this one. Okay, just one body. This one is not needed for the machining operation, and that's it for this first screen. Then we go to the next tab, which is called stock. Okay, and the stock relative size box. Okay, which would be about this one, I guess. And then stock side offset, we might put here 0 and then 0. Okay, so basically our stock is exactly the piece of wood that we will be working with, which that's what we need right now. And these are the dimensions for the stock, right? Which is 200 millimeters times 300 millimeters times 100 millimeters. Okay, if I were to, let's say, increase the offset by 10 millimeters, you see how it grows, right? Or maybe 100 millimeters, that would be the stock I'll be working with, but in this case the stock would be the same as my block of wood that I will be modeling. Okay, so far so good. Let's just keep it like that. And here in post process, just pick a program name, something that you might remember. I don't know, today is the 23, so for example 2310. Okay, and program comment CNC router cut. Okay, so far so good. You just leave this as it is. It's 0, and then stock, everything is 0. These are the dimensions of the stock, and the setup, milling operation, and we have defined the X, Y, and Z axis. Okay, they should be exactly like this one. On the if you see your design from the top, our origin here should be the left down side of the wooden block. Okay, so this should be your origin exactly in this place. Don't put it up here, don't put it here, it has to be in this place. Okay, so that would be make everything easier for us to machine. As you can see, this is the origin for our model, but we don't care about the origin for our model, we care about the origin for the machining operation. Okay, so you have to have it here on the top surface and in this exact point. All right, now since this is okay, and then the stock, it's basically the whole block of wood, we just click OK. All right, so hopefully you're following me so far. And then what we need to do next is basically go on with the next things that we need to do. All right, so once we have our setup, the thing that we're gonna cut, we basically have to select the tools. Okay, so how do we select the tools? Well, we have different tools in the lab. I'll post them so you can choose the best one, but right now I could well, basically I would suggest maybe the ball insert. Okay, I'll show you how it looks like. So what we need to do is basically to the you could see the different operations, right? To the adaptive clearing, pocket, face, contour, etc. Okay, we might need this one or this one. There's a slight difference, but not much. Maybe pocket is a better one. You could also go for the 3D one, but let's start with 2D pocket and see if this works. Okay, so now that we're here, the operation would be a 2D pocket, which is basically we're creating a pocket into our part. And basically the first thing, again, we have different tabs in this new window that just appeared, and we need first of all to select the tools. Okay, so we go here in tool, select, and a new window will appear. Okay, so this is very important. We need to basically create a list of the tools that we will be using for our CNC cutting operation. Okay, now we just go here to add new tool, new mill tool, right? We click it and we have different types here. Okay, so in the description, for example, I'll just do one of the examples and you have to check which different tools are available at the lab, but so on I will use the one that says I will put cortador, bola, 3/16 of an inch. Okay, that's all I need to know right now. And then I go for cutter, and here you'll find the different types. Okay, a flat, a cutter with a flat end or cortador plano, the other one with a ball end or cortador de bola, and these basically are the two cutters that we have in the lab. Okay, so either these two, you have to check which ones. I'll just upload the list, but right now let's go for ball end mill. Okay, so I'll just select this one. The number of flutes I'll explain to you, but it's basically how many files we have here. So normally the ones we have 4 flutes. Okay, this is just in order for the machine to do some calculations. We have high-speed steel, so this material is okay. We don't have coolant through the tool, so let's just leave it like that. and then here in millimeters we'll change to inches, right? And basically here the diameter would be 3/16 of an inch. Okay, so let's see, calculator. Okay, so basically 3/16 of an inch, that's 0.1875. okay, 0.1875. okay. So that's the only thing that we need right now, the diameter, okay, in inches, or you can just change that to millimeters. It makes no difference, and this usually automatically adapts to what we have, and it's really not needed. Okay, so this is the diameter we have so far. In the shaft there's nothing there. Holder, feed and speed. In spindle speed we'll use, for now, we'll use 1000 RPMs. This might change, I'll just let you know, but so far just leave it at 100 RPMs, and everything else just leave it as it is, okay? And then here in post-processor, just leave it again like that, number 1, diameter, etc. Okay? So basically the only thing that you need to do here is to put some description of that cutter, and here you have to select which kind, if it's a flat or if it's ball. Put 4 flutes, just leave this as it is, and in inches just put the diameter. Okay, so the ones that we have is 3/16 of an inch, which if you convert that to inches is 0.1875 inches. Okay, now so far that's all we need in order to define our tool, and this is the one that we will be using. You can see here it was already converted to millimeters, and we get an idea that this is 4.7 millimeters in diameter. Okay, so this part would be interesting to know eventually. Okay, so far let's just leave it like that, and we click OK. So now we have the tool. We have no coolant. Okay, so just click disable. The spindle speed, we already put it there, it's 1000 RPMs, and everything else you just leave it like that. Okay, so for this first part just leave it like that, nothing else to change. Okay, then the geometry, this is basically where we will need to select everything that we need. Okay, and then we'll select the heights, the passes, and everything else. But I'll just stop here so far, and we'll continue in the next in the second part of the video explaining you the rest. Okay, thank you guys. Just sorry, before, just click OK. It will say like it's incomplete, just don't bother, and we'll come back to this in the following video. Okay, thanks a lot.